Today's video starts on page 20. In our class, we played the integer card game, or we are going to play the integer card game if we haven't already. So it says, using addition using the integer game, we were finding opposites to make 0. Now we're going to use number lines to show the addition of integers. So we have an example here with some of our arrows drawn to show us what is the sum of 2 plus 4. So 2 plus 4, we've known a long time, since kindergarten. You counted over to 2, and then you counted over maybe 4 little humps or jumps over 2. Yes, positive 6. So we're at positive 6 in this example. Well, we're going to do that same thing. First we count over to 2 to the right, because that's a positive value. And now we have to do the opposite. Adding 4, we're going to go left because it's a negative value, and in this case, we get to negative 2 as the sum. For each example above, what is the distance between the 2? The distance between 2 and the sum. Well, here's my 2, and here's my sum of 6, and this distance was 4. Here's 2. And here's my sum, which was negative 2, and this distance was also 4. Why? Because positive 4 and negative 4 have the same absolute value, which is distance, right? Positive 4 and negative 4 have the same absolute value, 4. Does the sum lie to the right or left on the horizontal number line? Well, in this example, it lies to the right, which is positive. In this example, it lies to the left, which is negative. But they also ask about vertical number lines. So I drew them in. You don't have them on your paper, but you can see them here. To the left side, I have positive 2 and positive 6. Oops, positive 2 and positive 4 equals positive 6 as a vertical number line. So the answer, the sum 6, is above on the vertical number line, which is positive. And on the vertical number line here, going up 2 and then down 4, my sum, which is negative 2, is below, which is negative. Given the expression 54 plus 81, can you determine without finding the sum the distance between 54 and the sum? Well, the distance is going to be 81 units because I'm adding 81 units, right? It's going to be 81 spaces to the right, units to the right, because you add a positive 81. And 135, yes, is 81 units away from 54. 135 is the sum, by the way. Is the sum to the right or left of 54 on the horizontal number line? Well, it would be right, because I'm adding a positive 81. On a vertical number line, it would be above. Yes, 135 would go way up, so it would be above because I'm adding a positive 85. Given the expression 14 plus negative 3, can you determine without finding the sum the distance between 14 and the sum? The distance between 14 and the sum. Well, it's going to be 3 units, because that's what I'm adding, to the left, because I'm adding negative 3. As you add negative 3. So it's going to be to the left. 14 and negative 3 would get me at positive 11. Is the sum to the right or left on the number line? It's going to be left of the sum is going to be left of 14. I get the answer 11. On the vertical number line, it would be below because it's at -3, right? Because of the negative. How to model addition on the number line. On a number line, arrows are used to represent the integers. We know that, so I'm just going to skip down to the exercise here. And I'm going to show what is -5 plus 3. So -5 plus 3. We always start at 0. So I'm going to go to -5 plus 3. 1, 2, 3. And my answer ends here at -2. -6 plus -2. Okay, so -6 on the number line plus -2, go left, because it's negative. This equals -8. Oh, I'm going to put the answer here. This equals -2. And 7, positive 7 plus -8. Positive 7, I'm going to go to the right, plus -8. 1, 2, 3, 4, 5, 6, 7. That's opposites will get me to 0. And one more, -8. This will give me a sum of -1. So, and I'm going to write in P plus Q because they're talking about that. Any integers, we'll call one of them P, like 6, and Q, like -2 or positive 5, it doesn't matter. Two integers, P and Q. The addition of integers is represented on a number line as counting up, where counting up a negative is really called counting down. So counting up is for positives, counting down is for the negatives, or going left. This is right, and this is left. Arrows show the sum of the two numbers on the number line. Yep. And the sum is the distance that Q is from the first value, P, the add end, to the right if Q is positive, which we saw, and to the left if Q is negative. So if it's positive, like we saw in the other examples on the first page, like 5 plus 3, I'm going to the right, and my sum is 8, which is right of that. But if I have 5 plus -3, or -5 plus 3, or -6 and -2, or 7 and -8, my sum is left because my Q was negative. That's what this is explaining here. Represent the sum of 3 plus 5. Well, this is just like when you were in kindergarten, 3 plus 5. So this explains it even a little bit more. 3 plus 5, 1, 2, 3, 4, 5, is going to give me 8. I know that. How long is the arrow that represents the 3? Well, that's 3, and they're called units or spaces. What direction does it go? Well, right, because it's positive. How long is the arrow that represents the 5? Well, that's 5 units. And what direction does it point? Right, because it's positive. And what was the sum? Positive 8. 3 plus 5 is 8. We learned that in kindergarten and first grade. If you were to represent the sum, just the sum using an arrow, how long would it be? Well, the sum is 8. Well, it would get all the way down there. It would be 8 units, right? And it would, how long would the arrow be? In what direction would it point? To the right, because it's positive. What is the relationship between the arrow representing the number on the number line and the absolute value of that number? Well, they're exactly the same. This length of this arrow is 8, and the number is 8. And what's 8's absolute value? They're exactly the same. They have the same value. The length of the arrow and the absolute value of 8 is 8. The same, whoops, I'm trying to write same value in one word. Same value. Do you think that adding two positive numbers will always give you a greater positive number? Yes. Because you're moving to the right twice. And the more right you go, the more positive, bigger you go, because you are moving to the right twice. Oops, I think I went off the board there a little bit. Represent the sum of -3 and -5 using arrows then that represent -3 and -5 on the number line. Use the same questions to get feedback in the integer card game. I would combine -3 and -5 to give me -8. Okay, so -3, we'll start at 0, -3 plus -5 would get me to -8. Okay. It's boring. How long is the arrow that represents -3? It's 3 units. What direction does it point? Left, because left is negative. How long is the arrow that represents -5? 5 units. What direction does it point? Left. What is their sum? -8. If you were to represent the sum using an arrow, no, all the way down there, how long would that arrow be? 8 units. In what direction would it point? Left. Do you think adding two negative numbers will always give you a smaller? Ooh, smaller. Yes, when you go left, it's smaller. Yes. You move left twice on the number line, so you're going to get smaller. But you're moving left, you're going to keep getting smaller on that number line. You're moving left twice, so it's going to make a smaller one. What do they have in common? In both of these examples, we added the numbers together. 3 plus 5, 8, -3, -5, -8. In both examples, the two numbers, the 3 and the 5, the two numbers, whether it was positive or negative, got added together. Oh, I think that word's going to come off, so I'll move over here. Together. Next page. Rule for adding opposite signs. So 5 plus -3. 5, I'm going to draw this on the number line, plus -3. Got to go left. 1, 2, 3. And our answer is -2. How long is the arrow that represents -3? 3 units. What direction does it point? It points left. Which arrow is longer? The 5's arrow is longer, right? The positive 5. What is the sum? Well, the sum was -2. If you were to represent the sum using an arrow, I was to use, oh, it's +2, silly. +2. +2. Yikes. 5 and -3 make +2. If you were to represent the sum using an arrow, how long would the arrow be? It would be 2 units. So if I wanted to get back to this 2 units, I would go 2 units. And what direction would it point? It would point to the right. Represent 4 and -7 using arrows on the number line. Okay, so let's see if I can get this right. 4 and -7. 1, 2, 3, 4 gets me to 0 because they're additive inverses. 5, 6, 7. So my sum is at -3. -3. So in this one, my sum went to the left 3 units. And I'm going to skip these 2 questions, but I'm going to go down to this 3rd question. Write a rule that will give the length and direction of the arrow that represents the sum. So the sum here would be represented by an arrow 3 to the left that have opposite signs. So if the larger absolute value, the distance from 0, if the larger absolute value is negative, as in -7, right? In this last example I just did, -7 has a larger absolute value. It's 7. 4's absolute value is 4. If the larger absolute value is negative, the sum will be negative. And go left. If the larger absolute value is positive, the number with the larger absolute value is positive, like the first example up here, 5 has a larger absolute value than negative 3's absolute value is 3, because it's longer to the right, the sum will be positive and it will go to the right. The sum will be positive and go right. Okay, last page. Decide whether the sum will be positive or negative without calculating the sum. Okay, 2 negatives, negative. 2 positives, what we learned in first grade, positive. 2 negatives, negative. 2 negatives, negative. Because I'm moving twice to the left, it's still going to be negative. All positives, positive. 2 negatives, negative. Well, that was easy. Find the following sums. Well, 15 plus 7 is 22. Negative 4 and negative 6, add them, same signs, add them together. I'm going to go left and left. I'm going to get negative 20. Keep that sign of negative. It's still going to be negative. Negative 18 and negative 64. It's still going to be negative. I'm moving left twice to the left. It's going to be negative 82. Add those numbers together. Negative 205 and negative 123. Ooh, going way left, getting really small. Negative 328. Circle the integer with the greater absolute value and then decide whether the sum will be positive or negative without actually calculating it. Well, 2's got a larger absolute value, so it's positive. The sum will be positive. Negative 9 has the absolute value of 9. That's larger. It's negative. The sum will be negative. Negative 6 has a larger absolute value, 6, compared to 3. So it's negative. The sum will be negative. Negative 11 has the larger absolute value. It's negative. The sum will be negative. Find the following sums. So negative 10 plus 7. They have different signs. If I go 10 to the left and then 7 to the right, I'm going to end up on this is a larger absolute value, so I know my answer is going to be negative, and yes, it's going to be 3. Larger absolute value here is negative 16, so my sum is going to be negative, and it's negative 8. My sum is going to be positive in the C example because positive 65 has a larger absolute value, and the answer is going to be 53. I'm subtracting the numbers this time. I'm subtracting, right? 10 take away 7 is a 3. 16 take away 8 is an 8. 65 take away 12 is a 53. And the larger absolute value here in letter D is the negative. So my sum's going to be negative, and it's going to be negative 21. And that's it for today's video. Whew.